Hello, welcome to today's panel discussion on printers and stencils. Miniaturisation, coplanarity and paste release are among some of the key issues facing engineers today. This panel is going to discuss some of these issues and the options for using step stencils and the benefits of eletroforming versus laser cut stencils. The panel will also discuss self-correcting, AI in the printer and best practices for stencil handling and storage. I'm delighted to be joined by three very distinguished panelists. To my extreme right we have Mark Brawley from Speedprint. To his left we have Jens Katschke from ASM Deck. And to my extreme right here we have Bruce Seaton from ITWEAE, which is the new title, correct?
Correct.
Okay, gentlemen, thank you for joining me. So I'm going to start off straight away with my first question. What are the top three defects typically associated with the printer? Let's pose that one first of all to you, Mark.
Well, I would say perhaps paste insufficiency, bridging perhaps, clogged apertures, maybe the first top three I would maybe throw out there.
Right, okay. Anything to add to that, Jens? Any other typical?
No, I think insufficiency and bridging, I think they are the most critical things, or the most items you see. Very much driven now with the materials getting cheaper and cheaper, so very much driven from also PCB boards, which are getting differences in the terms of solder mask, etc., which is driving, of course, forcing this kind of issues in the printing.
So you're saying that the cheaper materials are not allowing for what, paste release, or what is causing the insufficient paste?
The problem is if you have a very high solder mask there, so the stencil will lay down on the solder mask and will potentially not reach the pad to make a gasketing for the printing, and that of course is creating problems. So that is also one of the things which can cause this. Yeah.
Okay. Bruce, do you have any other?
No, I'm agreeing with Mark and Jens on this. I mean, insufficiencies have always been a problem throughout the infancy of stencil printing through to today. So materials have got better, stencils got better, but the insufficiencies, bridging, even offsets can be a problem. With the most accurate of printers, you can still have offsets related to board stretch, as Jens said. A board which is not made extremely well, especially one which is depaneled or partially routed already. It can be a challenge on the printer to obtain that accurate offset.
What about materials storage? I mean, if the solder paste isn't in a syringe or something like that, if it's not stored properly and it's maybe gone off a little bit, is that something that could contribute to insufficient materials?
Absolutely. I mean, paste storage is critical, and coming to the printer at the right temperature, and the traceability systems, making sure that you're putting it on at the right time, and it's already conditioned for room temperature at least. You don't want paste straight out of the fridge, otherwise you're introducing the defects from the moment of go.
Right, okay.
I would just add to the insufficiency comment is that we all now manage that. We have methods to manage the paste being on the stencil to prevent that from happening. So you ensure that you have enough solder paste there before you go ahead. In the past, a lot of people use the 2D inspection just to validate that there was enough paste there. Maybe check for corners of the board or a large aperture or such. And now you don't need to do that because there's some new things that we brought out to manage that.
Right. So, gentlemen, next question. How big a challenge is miniaturisation? Is it better to print or to dispense microdeposits? Is my next question.
I don't mind taking that for a start, Trevor, because as a company who are in the printing business and the dispensing business, we often see which is the best solution for a customer to offer. And indeed, as each of our companies have also integrated dispensing technology into our printing machines as well, you normally got that flexibility. But as far as miniaturization goes, the smallest deposits are still the printed deposits. You will not necessarily get below maybe a 300 micron dispense dot, which is, maybe it's good for an 0402, even an 0201. But as we get on to 01005s, you're not going to be dispensing solder paste with that.
Really?
So printing is the solution for miniaturization.
Okay. Even with different types of paste, you can't get.
I mean, we're talking type 5, 6s and 7s even to get down to this level. Is still some limitation on miniaturization.
It's a solid through a small nozzle is still quite a challenge.
Oh yeah.
Physics come into play. We can position it quite accurately, but still getting the material through the tip and the volume you need is quite a challenge.
Yeah,
For
yeah.
the small stuff.
Yeah,
So we would
dispensing metal,
suggest-
essentially dispensing metal, you know, which
Yes,
is
right.
different.
So I would agree with Bruce that printing is the best way to deal with miniaturization, and then maybe supplementing with our dispensers to add additional solder where extra volume is needed.
What other
In
challenges?
particular, sorry.
What other
in
challenges is miniaturization bringing to you guys?
The challenges is definitely, I mean, the inhomogeneous assemblies now, that makes it a bit more difficult because of course you have the connectors which we need quite a lot of paste, and you have the very fine pitch components. So that is really, I think, this challenge, because printing fine on a wafer, no problem. Printing big on for other things, no problem. I mean, the combination is really the challenge here. Yeah, and and for that one is also, just to add on the dispensing, I think it's also a matter of the speed. Yeah, because I mean, if we look into a production line, and the printing is of course the fastest process you can get. So whatever you need to do on dispensing later on, it will cost cycle time. Yeah.
Great.
So the term that's been referred to here is what we call broadband printing, printing very small apertures, but also having to have a large volume in other areas of the PCB for the solder volume, correcting solder joints for large heavy components, for example. But having that whole range, and typically we see these kind of technologies maybe on large network boards, for example, where you really have to look at clever stencil technology to have that broadband solution.
Right.
You know, the worst case of this is that a customer has to invest in a two-print solution, two printers to run such a process, which happens. You know, it's good for a printer manufacturer, but not good for the end
But
user.
maybe do a double pass. You know, use the dispensing side to do the second print on bigger devices that might need more volume or more height.
Yeah,
That's what I was
Yeah. Okay. What techniques should stencil manufacturers use for improving paste release? Alex, who wants to start? Let Mark.
Well, I think the data's been out. The nano coatings seem to be the thing that
Right.
really
Nano coatings.
improve performance on stencils. So
Okay.
there's lots of data to support it, and that seems to be what most folks are doing these days.
Not all these nano coatings last forever. You know, some of them need to be recoated. Some of them claim to last a lifetime. What's the truth behind it?
I mean, it's really depending on the materials you're going to print. So it can be a very abrasive material, so it's very difficult to give you just a number how many prints you can do, because you have so many influence factors there with the nano coatings. For that reason, we also have basically two types, or you can apply by the customer itself, so you can reapply, or you have something which is applied by the supplier, and that can be used only until it is dying, so you cannot reapply. So both ways are possible, but in general also to the nano coating is also the materials itself, where you're basically coating where you do the nano coating on. That's also interesting, because there's also no new materials on the market which does have much finer grain size compared to a stainless steel. And that is helping also to improve the release characteristics.
Okay.
And if you add then together with nano coating, then of course you get pretty good results, and you can basically also move the area ratio limit down and down. Yeah,
So it depends on the grain of the steel that you're using on the stencil.
Yeah, because the grain size, of course, if you use a laser system, of course, it is a big influence how much is the particle size of the material itself.
Of course, yeah.
Yeah, if you just go with a laser through it, you have a very rough surface, or if the material is finer, you of course get a very much smoother surface, which you then additionally can coat with a nano coating, and you can smoothen it out to even better have a better paste release characteristics.
Yeah, I mean, Bruce, what about the idea of using a trapezoidal cut that would help with the paste release as well, presumably
In theory, yes, but there's there's a lot mentioned all of a sudden about nano coating, which is particular to some manufacturers of stencils, but there's other technologies out there as well. A typical one which is being very well presented at the show here is plasma coating on stencils, which is a very viable alternative. Not only looking at plasma coating of existing stainless steel stencils, but looking at new nickel materials which have very, very fine grain. We're talking about stainless steel stencils, then fine grain stainless, then onto the nickel materials, which are not electroformed but laser cut nickel. So there's materials out there, and then in addition can also be plasma coated as well. Right. And the claims are that these are the stencils which are going to give the absolute best release.
Best release. Okay.
The other thing I would add to that too is the lasers themselves have improved dramatically, right? So they do a better job of cutting. Chemical etching is gone, right? After used a laser cut, then you chem etch after that to smooth out the aperture walls, and that's no longer necessary. So there's a number of advancements I think that have contributed to, better paste release.
But one of the key points here is there's so much focus on the stencil, and the stencil is only as good as the squeegee mechanism above it or the enclosed head. If you don't fill that aperture correctly, the stencil's not going to perform for you. There are many studies that we've done ourselves just to show the importance of the fill of the aperture more so. If the fill is good, then the release can also be good out of a good stencil. If you're not filling it correctly with the correct squeegee parameters, the right type of squeegee, the right type of forces, attack angles, then your release is not going to be good anyway.
Well, that kind of segues a little bit into my next question, which is, are paste dispensing systems such as ProFlow, etc., desirable to avoid manually damaging the stencil? Because if you're applying your paste manually, you're always at risk of damaging the stencil, so it's not going to print well.
I think in this term, when we just talk about the closed print head, as you mentioned, like ProFlow as an example,
I
think the big benefit is there that you just have very less paste on the stencil. Yeah, that means you need less cleaning. So when you just take it out of the process, the stencil is almost clean. There is only a little bit, a few grams of paste on the stencil, and that of course is increasing, or is basically supporting the cleaning and also help to prevent any damaging here. Yeah, but at the end of the day, the closed print head, I think, is not really the thing to avoid damaging of the stencil. There are other advantages you have with these systems in terms of cost of ownership and less paste wastage and that kind of stuff, which is helping. Yeah.
Yeah, I think as you mentioned earlier, that you're using less paste in using an enclosed print head, but you're also, the fact that it's enclosed, it's preserving the paste better as well. It's not an open environment. Any views on that, Mark?
Well, I agree. I don't think you could justify an enclosed print head because of damaged stencils. It just doesn't really happen. And I don't see it happen in the squeegee process either. So there's other reasons to justify that, as Jens was explaining. But damaging stencils I don't see as a problem for anybody. They probably drop them or bang them against a table before that anything happened from a squeegee or an enclosed print head.
Well, I was just really assuming that, when somebody's putting on, spreading on paste by hand, in front of the squeegee, then if they're not an experienced operator, they could risk damaging the stencil. That was really where it was coming from.
But that is also, you can control this also with paste management systems, so that you just have a paste dispenser which is basically applying the paste to the stencil rather than doing this by hand, which also does have advantages because you always have the same viscosity coming onto the stencil, and not by an operator who is maybe steering a minute or steering 5 minutes, and you have a different viscosity, which is then also influencing your printing process. Yeah, so so I think, especially when we're also looking into the new industry, which we're looking smart factory, industry 4.0, etc. I think we need to look into these automated systems. I think we should fairly quick come away to have an operator
you get some data
applying
feedback
paste,
as to the exact amount of deposit you put down and that sort of thing. It's easier to do, for sure.
Coming back to your key point of the question about stencil damage, I do tend to agree that having an enclosed head is a very clean environment on top of the stencils. We all know that traditionally running an open squeegee, the paste will roll out to the end of the blades. It will create those two lines of paste, and an operator goes in with a metal blade, scrapes it either side to put it back in the process, and you do see the potential for damage there. Now, squeegee design is not changed so much over the years, but side dam design has become important. Put sprung-loaded dams which are keeping that paste within the print area. You can get a process which is almost as clean as an enclosed head. Enclosed heads have been in and out of fashion over the years. It tend to be used for customers who tend to want pin-in-paste processes, for example. Paste savings is definitely a critical point of justification for these heads. But I do agree that it's not a major consideration as I'm going to reduce stencil damage by using this enclosed head.
Right, okay. Moving on, Mark, board support systems, are they critical to maintaining coplanarity across
well, the easy answer to that is yes. For the printing process, we went everything as flat as possible.
But does everybody use it though? Or some
board supports?
Yeah.
Well, of some type. There's many different ways to skin the cat, whether it be hard tooling, dedicated tooling plates, or some of the flexible tooling that's on the market. But absolutely, it's critical.
Right.
So it's a best practice scenario, is that you have to set up the machine properly if you expect good results.
Right.
And tooling is absolutely critical to that.
Presumably the ones that contour to the board are going to be more effective than hard tooling, I would guess.
Well, I would say that they have their place as well. So if there's assemblies that are so dense where you don't have hard tooling, okay, maybe that's an alternative. But if you do have some bowing issues, perhaps those tend not to push any bow out, so they'll comply around a bow in that case. So, it depends on what your process is, what your assemblies are like, and that really will dictate, I think, the tooling solution that's best for that process.
Right.
I would fully support what you said. I mean, the tooling is, I think, the key for printing. If you're not really have a good tooling, a good support of the board, you will never get a good print.
Right.
And that is what you see in the practice. That very often you just try to find somewhere a balance in between what does it cost and how can I support the board. And that, of course, is always implementing problems. Yeah.
Right.
I mean. The tooling is the key, I would say one of the keys. Yeah.
Bruce?
Absolutely agree. Most critical area of the machine. It's in the SMT line, the printer is probably one of the hardest areas to provide good tooling solutions. That's why there's so many systems existing on the market, as from dedicated tooling to the grid-based systems with pin-based. We have our own flexible automatic tooling, which is a very popular option in the market as well. But I think one of the things to mention about the tooling in general is that there has to be enough of it. A dedicated plate is probably the best, but it's the longest lead time tooling. It's not good for NPIs. It's not. So we tend to see high volume manufacturers switching to dedicated tooling because it's probably the best support that you can get, and they're going to run that product for a long time. But somebody who's doing a lot of changeovers needs a flexible solution. What we see in one of our key markets in the automotive segment is some restrictions on what type of toolings can be used. There's a lot of our customers won't allow tooling which is touching a component or a lead of a component. Right. So you have to choose something of dedicated plates or something which is flexible for positioning pins.
Very difficult to do that without doing a custom support system, to be honest, I would think.
Or an automated system which is going to build the tooling nest for you.
Yeah.
It could be also beneficial if we talk about dedicated tooling for application that you also can add vacuum in order to flatten out the board to support that. Yes. So it's definitely, I mean, dedicated tooling is the most expensive one, but it's also one of the best one you can get. And everything else is somehow just a trade-off to see.
It's a compromise.
It's a compromise at the end of the day.
What a lot of people use electroform stencils when they get down to really small geometries and specific areas. What is the optimum cutoff from using, say, a laser stencil to using an electroform? When would you make that decision?
I think it's a bit about also what is the area ratio you need to reach there. Due to the fact that we also have these new materials like the stainless steel fine grain materials, which are as almost as close as E-formed. I think the border they moved down a bit. But in general. You have on the E-formed, of course, it makes sense if you just have a higher amount of apertures. That is definitely something where it makes sense. And also if we look into finer printing with thinner stencil sizes, because with the E-formed you can pretty much control the thickness and you don't have so big steps like you have on normal materials, stainless steel materials.
Yeah, and presumably if you're doing step stenciling or something like that, it might, building it into an electroform is maybe easier or smoother. No?
Electroform, at least as we see electroform also as a possibility for a kind of 3D printing. So if you have cavities you want to print in, that can be done by E-form technology. You can also do some E-form technology in replacing screens. That's also possible. So there are different scenarios to do. But for a step stencil, I would say not really that electroform is the first choice there.
If we're talking about step stencils, then E-forming isn't the only option. I mean, laser cut and milled machining processes are creating steps, starting off with let's say maybe you want a 200 micron base material and you're taking most of that area down to 150, 125 microns, leaving some high areas of the stencil, but also machining down into the step as well. And this is all can be done on stainless steel stencils.
Yeah, yeah. Okay. Anything to add to that, Mark?
Well, I think it's also perhaps a price-performance consideration as well. Of course, the electroforms are
they're a
probably
lot
the
more
most
expensive,
expensive stencils out there, and could be application-specific, I would say, right? Not every assembly is going to require that type of technology, right?
And a time performance as well, because the turnaround time is longer with.
It's typically longer, yes.
Yeah. Okay, so let's move on. We're coming on to the last couple of questions of our program. What are the typical difficulties encountered using step stencils? So what are the problems with step stencils?
Well, I think, being able to deform your squeegee blade to get into the cavity,
Yep.
the real estate perhaps around the cavity. So some are just a straight drop, some are a bit of a slope, right? So you need a little bit more real estate to do something like that. So I think those are some of the challenges around step stencils, and then of course the expense. And we would perhaps suggest, again, a single thickness stencil, and then use your dispenser to supplement the additional areas.
Right. Yeah, that's a good point.
So optimize for the small stuff and then supplement for the larger stuff, basically.
Yeah. Now, I've seen some fairly rough step stencils, where they've welded extra bits onto the top, and it's kind of,
At least they've done it on the top and not on the bottom. I've seen that mistake as well, stepping up on the bottom. This is a disaster. So.
But it's also, also from the stencil technology, before you go into a step stencil, you should try to do whatever you can in the stencil design in order you can overprint to offer more volume and that kind of stuff before you actually switch over to a step stencil. Because with a step stencil, as Mark said already, you always have the thing that you just your blade need to be flexible. It need to adjust to the height differences, and there are some areas where you definitely then have potentially problems when you have fine pitch around these steps, and that can make problems.
Right.
I think it's been said, the areas of concern with the steps, both up and down, are cleaning all the solder paste off the top of the stencil. That's the key point. You want to be able to scoop out of a step down, and you also want to clean around the step up. But some of our customers are running very successfully also steps combined with enclosed heads, which you would think is a very dangerous thing to do, because the enclosed head has not a trailing edge blade, but it has leading edge blades which can catch. So it's important that the stencil design is ramping up, and whether it be very fine steps or a genuine real ramp up into the step up. But it's a successful technology, and it can work in combination with the closed heads as well, with careful process control.
Okay. So let's move up a little bit. When provided with the correct data from the SPI, what metrics can auto-adjust in the printer today? What other metrics do you expect to be able to support in the future? Currently we're looking at we're correcting offsets, in some cases squeegee pressure. What other areas do you think that we'll be able to automatically control with closed loop systems in the future?
Well, print speed, print pressure. I'm talking in addition to X, Y, and theta correction, which is already there, right? So print speed, print pressure, perhaps separation speed can be manipulated as well.
Okay. So typically everybody says that up to 70% of the defects originate at the printer. Once we start getting this system a bit more optimized through automatic dynamic correction, do you think we'll be able to start to reduce the number of defects that start emanating from that end of the process? Question? Anybody?
Well, hey, I would argue that if you set up your printer right, you don't need an SPI. Would be my what I would say.
That would
but
be
if you set up the printer right, the printer's in good condition, it's optimized, it's calibrated. It should do what it's supposed to do. We all have pretty good specs on our machines.
In addition to this one, the only thing is again coming the material into play. When we have the stretching things, because you can imagine we have a stencil which is fixed on a CAD design, but we have stretching in the board. So somehow you need to make a trade-off in the alignment to get this as best as possible. But so the SPI of course can help us to just maybe in some critical areas where we need fine pitch to support that, to say okay, can there be some additional offsets applied in order to correct this, which the printer cannot do because we only see the fiducials, we don't see the image. And that are some things.
I think with all this machine-to-machine collaboration and smart factory stuff. I mean, we're only working at the equipment end at the moment, but eventually, once we've mastered that side a bit better, I think it's definitely going to come down to the materials side and how materials actually perform, and characterise and digitising these. But that's way off down the road.
Yeah. I mean, quite honestly, Trevor, we all know the fishbone diagrams of all the errors and, the conditions that need to be met to get a good print, and they're all influential with each other. Something that hasn't been mentioned yet. So first of all, an SPI, it's very common now for an SPI to communicate with the printer, and so the first stage of this is X, Y, theta correction, but not only for that, but stroke based. So front stroke to rear stroke can have different sets of characteristics. And then what hasn't been mentioned yet is the driving of the wipe based on the SPI. So under stencil wipers can be triggered off their own printer control or triggered off what the SPI sees, so that you can get an additional wiping. Right. But it's not even in the future, it's now both my competitors and we have architecture in our machines which is allowing control of print speed, print pressure separations. Certain SPI companies are using our open application to control those parameters. It's a design of experiments which is being done by the SPI company to see what is giving those best results, controlling the printer. But quite honestly, in a production line, I think that's something a little bit down the line for the future. I think there's too many other variables which have to be very well controlled before we start having the SPI really taking full control of the printing machine.
I think, just to follow up what you said, we can all trigger under-screen cleaners based on the 2D inspection we also capture, right? But it is an important point, because that is another element that you can control.
Yeah, I think, I mean, there's a lot more to happen with this closed loop process control, but I mean, what concerns me is when we start getting into the area of AI and the machine automatically making corrections without human verification. I think that gets a bit dangerous.
But in many systems you can first of all you can drive and say, okay, to the application engineer, do you want to apply this one? So you don't need to do it fully automatically.
Correct.
You can make the experiment and you get the result, and still the process engineer can decide if you want to apply it or not. That's one thing. And but in general, in the moment, if we talk about the SPI, I mean, in future it's also interesting to know what's behind the reflow oven. And to take this information into account and just take this into the optimization of the printing.
That's true.
Yeah?
That's true.
And that is of course also what will come there in the future.
No, I agree. The reflow oven, I think, is the next step. I mean, at the moment everything stops at the reflow oven, but there's a lot of data needs to come out of there. But I mean, at the moment you're only getting data about the actual oven. You're not getting data about every individual board and how it performs. And I think that's what we really need to get down to there.
Yeah. And the interesting point is also if you take this data and also give this to the pick and place machine to optimize here as well. So these are all things which are going hand in hand in the future, I think. To optimize.
I agree. Okay, good. So we've already asked about the recoating of nano stencils and things like that. I think we've pretty much come to the end of our discussion today. So I want to thank you all once again for taking part. Mark Brawley from Speedprint. Jens Katschke from ASM DEC, and of course Brian Seaton here from ITW EAE. And thank you for joining. So that brings us to the end of our programming here from SMT Hybrid Packaging 2017. Thank you for joining us, and we look